Guys, here we go. Today we are talking about the brain some more, specifically parts of the brain. Um, I do want you to listen to this whole thing. You are going to watch a couple of videos, and I have underlined what I think you should write down. So it's not a ton of writing, but a lot of information for you to get kind of in your head today. So here we go. This we already know. Your brain is about the size of both of your fists pressed together. We also call it gray matter because of its actual color. The reason it's pink is because of the blood surrounding it. The average brain weighs about 3 pounds, and there is no correlation between the size of your brain and your intelligence. Different areas of the brain serve very different functions, which we're going to talk about today. The brain itself does not have an oxygen reserve, so how would you think that the brain gets oxygen? You might be thinking the lungs. That's not directly true. It's actually the blood. The blood carries oxygen to the brain. But if there's a disruption in oxygen flow to the brain for more than 3 minutes, brain damage will result. The brain itself never completely rests. It can't, otherwise you die. And even though it's so small, it uses about 1/5 or 20% of all the oxygen consumed by your body. Also, the brain itself feels no pain. It's actually the skin around the cranium that's very sensitive and serves as a warning system so that you know not to hit your head, or hitting your head hurts because it wants your brain to know that it hurts. Somebody last class asked about headaches. The truth is the brain itself feels no pain, so any headache is not actually pain in your brain. It's something else. More random brain facts. The brain is protected by a bone structure called the cranial cavity. The brain cavity averages a thickness of about 1/2 inch. The thinnest portion is in your nasal cavity and at your temples. The thickest is in the back of your head. So put your fingers on the corners of your eyebrows and then move your fingers down and backwards towards your ears. You should feel a small indentation at your actual point of your temple. If you were to get hit there by a really sharp object or a hard corner or something like that, that could actually kill you because it's the thinnest portion of your skull. Also, if you're ever in a life or death situation, other than breaking a person's nose or hitting them in a very sensitive area, the best way to stop an attacker could be to use the palm of your hand and thrust it upwards into the attacker's nose, because not only would it break the nose, but it could ultimately kill the person as well. We talked last class about the brain being an electrical source. The brain can actually generate 25 watts of electrical power. The brain of a newborn is closer to its adult size than any other organ. You might have noticed that babies' heads seem disproportionately large to their body. It's because their brain is about a normal size as an adult. Also, their eyes are almost normal size as soon as adult, which is why babies look like they have giant eyeballs. Most people have at least 150 million more neurons on the dominant side of their brain. So those of you that figured out you were left-brained last class, you have 150 million more neurons on the dominant side. And those of you that figured out you were right-brained last class, same thing. Also, random fact, the average man has more neurons than a woman. Any guesses as to why? Give you a second to think about it. The actual reason that men have more neurons than women is because if you think about, we're going to gender stereotype, which I don't really like doing, but who as a child, boys or girls, plays rougher? Boys. Who as a child gets hit in the head more through their play or sports or whatever? Boys. The truth is boys need to start with more neurons because their play dictates a easier way to lose neurons. And so if they had the same amount that women had to start with, by the time they were adults, all guys would be stupid, or anybody who played rough would be stupid. So, good news for you. All right, here's some stuff to start writing down. This is called the cerebral cortex. It is noted here by the blue line on the outside of the brain. Okay? It's the outermost layer of the brain. It's the wrinkly stuff. If you were to cut into my skull, remove my skull cap, and put your hands on my brain, you'd be touching my cerebral cortex. It comes from the Latin word meaning bark. So if you think about it, it's like the protective coating on a tree. That's like what it is on your brain. This is the portion of the brain that makes us uniquely human. It controls memory and habits. It has emotional responses, language and word meaning, perception, associations, and most of our complex motor functions are located here. I forgot to say this earlier. Don't forget, if I ever go too fast for you, just hit pause so you can write everything down that you need to write down. And then hit play again when you're ready to move on. The cerebrum. If you remember last class, I warned you that there are lots of words that start with C's during this unit, so you're going to need to keep them straight. Some of you may want to start making flashcards. The cerebrum is the largest portion of the brain. It's the bulk of the brain. It makes up 70% of the entire weight of the brain. It's the area indicated in green here. It is not what we call the midbrain, and it's not what we call the hindbrain. It's all of the upper brain stuff. Its name comes from the Latin word meaning brain, and this is the thinking part of the brain. It controls decision making, higher level thought processes like personality, imagination, judgment, and decision making, and the cerebrum is the thing that's divided into two hemispheres that are connected by the corpus callosum. Now, we talked about the corpus callosum last class, so some of you will not need to write this down, but if you weren't here last class, or if you want it as a part of the brain notes, a different part of the brain notes, you may want to repeat this. But the corpus callosum is a thick band of neurons that connect the two hemispheres of the brain. It comes from the Latin words that mean tough body because of how dense and tough this portion of the brain is to dissect. It allows the hemispheres to communicate with each other. Random fact, women generally have wider corpus callosums, and this offers a possible explanation for many perceived differences between the sexes, because women tend to have more cross communication between the hemispheres than men. If we're gender stereotyping again, the person that's better at multitasking is actually women instead of men. In fact, they've done studies where they play two stories, like tape recorded stories, told by the same voice about completely different topics. So they play them at the exact same time, and they have men listen to those two stories, and they have women listen to those two stories. And at the end, they say, okay, now tell us what you heard. And the men remember all of one story and very little of the other story at all. They blocked one story out completely. Whereas the women are trying to retell the stories, and they're getting their stories mixed up because they tried to listen to both of them at the same time. So that explains a little bit of that. Now, this video that you're going to watch is about a girl who has seizures. It's about a 5-minute video, so I'm going to let you watch it. When you're done watching it, come back to the notes. All right, welcome back to your notes. The next part of your brain is called the thalamus. The thalamus acts as a relay man up, which I'll explain in just a second. It sends messages from the body to the brain. It also controls things like consciousness, sleep, and alertness. And it comes from the Latin word meaning inner chamber. So, the way it's works as a relay man up is, for example, if I put my hand on a hot stove, I wouldn't just sit there and think about it for a little while. Like, oh man, I should move my hand off of this burning hot stove, and then my hand moves. No, it has to happen instantaneously. So the second my nerves feel the heat in the tips of my fingers, it shoots a message up to my brain, and it goes, in order to get to my brain, it has to go through the thalamus. So the thalamus is relaying the message from any part of my body that something needs to happen or move, and that is what the thalamus does. The hypothalamus is one that most of you will not forget. Hypo means under, so it's literally located under the thalamus. And how are you going to remember it? It's super easy. Hypothalamus is all of your H's. It's happy, horny, hot, and hungry. The hypothalamus is in charge of your pleasure center. So when you're happy or when you're sad, your hypothalamus is playing a role. It's also in control of your sexual arousal, your body temperature, and your hunger. Also many other things like emotions like anger and rage, addiction, and parental instincts. So your hypothalamus is all of the H's. Next up is your cerebellum. Your cerebellum here is located in red. It is located near the back of the brain, close to the spinal cord, and it comes from a Latin word meaning little brain. It actually looks like a small brain. It has its own set of wrinkles. It actually has two hemispheres, and it's very, very important. It controls things like coordination, visual acuity, voluntary movements, like if I want to raise my hand, grab a pencil, kick a desk, catch a ball, that type of thing. And it's largely responsible for remembering patterns and routines. So it controls things like the ability to play instruments, play video games, develop skills in athletics, or operate complex machines. Those of you that are good at video games, chances are when you were first learning how to play a particular game, you were really spending time thinking about the fact that you have to hit, up, down, left, right, circle, or something like that to make you do something. And now when you want to do whatever that move is, your body just does it naturally. That's because of your cerebellum. Also, if you're a very athletic person, your cerebellum has a lot of control over that. If you're a very uncoordinated person, you can blame your cerebellum for that as well. This video is short. It's about 1.5 minutes long, about a woman who went into the doctor at the age of 24, and after complaining of nausea and dizziness and things like that, they finally did a brain scan and realized that she was born without a cerebellum. So watch the video and then come back to the notes. Alright, welcome back to the notes again. This next one is called the pituitary gland. The name for this gland comes from the Greek root meaning to stimulate. It is the master gland for the entire body. It controls the entire glandular system. It manages functions like growth, that's probably its biggest one, temperature control, muscular and skeletal development, digestion, pregnancy, and sexual maturity. The pituitary gland secretes the hormones into the bloodstream that stimulate and control specific bodily functions. All of this, and it's only the size of a pea, like the pea that you would eat. If you just heard that noise, my cat just came through my doggy door, and the dogs chased him down. Okay. Anyways, back to the pituitary gland. So, what do I mean when it says it controls things like pregnancy and digestion? What I mean is that it secretes hormones to let your body know that it's time to digest food, or it's time to give nutrients to the baby, or it's time to have the baby grow. It's time for you to reach puberty. It's time for you to have a growth spurt. All of those things are what the pituitary gland does. No one that I'm aware of has ever been born without a pituitary gland, although some people have under-functioning pituitary glands, and so sometimes you have to give someone a hormone or a chemical that kind of tells the pituitary gland, hey, you're not doing your job right, so let's get back on track. This next one is called the pons. The pons is the relay man down. The relay man up was called the thalamus, and the pons sends messages down from the brain to the rest of the body. Now, why is it important that the pons and the thalamus are both there, intact, and working well? Well, think about if a car tried to drive south on a northbound highway during rush hour traffic. There would be traffic jams. There would be accidents. So when your messages get sent up and down to your brain and from your brain, they have to go on two different sides of the road. Otherwise, they'd run into each other and get jammed up. So when I put my hand on the hot stove, the message shoots up through my thalamus and says, hey, we need to react. And then my pons shoots the message back down and says, hey, move your hand, and my hand moves. Now think about how fast that happens. I don't know the exact speed, but we're talking about 100 or plus miles an hour from the tips of my fingers to my brain and back to my tips of my fingers, so that I move my hand before I get severely burned. Any of you guys Waterboy fans? If you are fans of the movie Waterboy, you know that Adam Sandler's character got in a fight with the character he called Colonel Sanders over what exactly the medulla oblongata does. Adam Sandler's character said, no, Mama says that the medulla oblongata is what makes an alligator ornery. Unfortunately for him, Colonel Sanders was right. The medulla oblongata, or medulla, you can call it either one. Neither one is more or less correct. In fact, the word oblongata just means oblong shaped. So like a football is shaped oblong, and a basketball is round, the medulla is oblong. It's not a circular part of the brain. So, It is part of the autonomic nervous system. It never shuts off, which is good because you would die, because it controls life-sustaining functions such as heart rate, breathing, hormones, glands, blood pressure, blinking, sneezing, coughing, swallowing, gag reflex, throwing up, etc. Make sure you hit pause and get down all of those things and then move on when you're ready. Now, we've talked about all of the midbrain stuff that we're going to talk about, so now we're going to get back up to the outer part of the brain, the big stuff, the lobes of the brain. The frontal lobe, as you know, is responsible for personality and reasoning, and you can live with severe damage to it. Like in our movie that we watched, Matt received a frontal lobotomy. He was still alive, but his personality would forever be changed. So, put your hand on your forehead. That is your frontal lobe, okay? So when I ask you guys next class to show me your frontal lobe, you're going to put your hand on your forehead. I'll say, what is it? You'll say frontal lobe. I'll say, what does it do? You'll say personality. Okay? Let's try it out. Ready? This is kind of dorky because you're all doing it on your own, but just do it anyways. Okay? So show me your frontal lobe. And what does it do? Personality. All right, right on. Next. Your parietal lobes. Your parietal lobe is responsible for your sensory motor responses. You're going to wear your parietal lobe up on your head like a girl wears a headband to keep her bangs out of her hair, or out of her eyes rather. So your frontal lobe is behind your forehead and it is in charge of personality. Your parietal lobe is up on top of your head like a headband. And when I say what does it do, you're going to say sensory motor. All right? So show me your parietal lobe. What does it do? Show me your frontal lobe. What does it do? Parietal lobe. All right, moving on. Your occipital lobes are responsible for your sight. Occipital lobe responsible for sight. It seems a little bit weird because it's the furthest back part of your head, and yet it is connected to your eyesight. But if you ever think about, like, if you've ever fallen and hit in the back of your head on the floor, or something like that, your vision is blurry, that makes perfect sense. Okay? Also, when you're showing me this one, I want you to keep your hand on the back of your head, not down at the base of your neck. That is actually your cerebellum. So move your hand up just a little bit on the back of your head to make sure you're covering the right spot. So, show me your occipital lobe. Hand goes on the back of the head. What does it do? You say sight. Okay? So, show me your occipital lobe. What does it do? Good. Parietal lobe, up on top of your head. What does it do? Should be sensory motor. Show me your frontal lobe, over your forehead. What does it do? Personality. All right. Now, we go to the temporal lobe. The temporal lobe is responsible for hearing. It is located here by the green on the picture. And it's responsible for hearing, which makes sense because it's right by your ears. Now, when you show this one, I want you to put the palm of your hand on your temple and put your fingers back towards your ear. That's your temporal lobe. You have one on both sides. Now, I don't want you to be confused. The left temporal lobe is responsible for your right ear's hearing, and your right temporal lobe is responsible for your left ear's hearing. Okay? So you can do it with one hand or both hands, but show me your temporal lobe. What does it do? Hearing. Good. Frontal lobe. What does it do? Parietal lobe. What does it do? Occipital lobe. What does it do? And temporal lobe again. What does it do? Awesome. All right. The following image is just a joke. This is from Mr. Went to you guys. Again, it is just a joke. Nothing about it is real. Just meant to be humorous. Don't linger on it for too long. This is the joke image of the male brain. I think one of my favorites is the lame excuses gland. And the footnote at the bottom, listening to children in the listening to children cry in the middle of the night gland is not shown due to its small and underdeveloped nature, best viewed under a microscope. All right, moving on. we are done with notes. So now it's time for a coloring sheet. At this point, what I want you to do is go up to the substitute, ask for a coloring sheet. You're also going to need to pick up 10 different colors. I have a lot more crowns than I do markers or colored pencils, so I recommend crowns in this case. You're going to need 10 different colors. You can also feel free to use your own if you have them. Also, if another person near you is done, you get 5 colors, have him or her get 5 colors, then you guys share. You're going to need to make sure you label that coloring sheet right. And when you're done, you're going to turn it into the box. So take a pause here for a second, go up and get the coloring sheet, do the coloring sheet, turn it into the box, and when you're done, you're going to come back and watch this video for the rest of the block. Now the first few minutes of the video are a little bit slow, but then it's going to start talking to you about how the Navy uses stress training, uses fear training, and oxygen deprivation training to train their SEAL candidates, their Navy SEAL candidates, some of the most highly trained people in all of the United States military, and how they use brain-based research to help make their people the sharpest that they can be. You're going to watch this through the end of the block, and next class we're going to watch a little bit more of it, continue on with some brain stuff, and talk about some other things. Thank you for doing all of this. I hope you enjoyed taking the notes this way, and I hope you enjoyed these videos. Thanks very much. All right, talk to you later.